Good morning, students. Today we will revise the chapter Newton's laws of motion, and we will discuss a few questions from the additional worksheet. The additional worksheet is given in the last part of the chapter. So first we will revise the chapter, then we will discuss few questions from the additional worksheet. Now we can revise the chapter. The MLM represents Newton's laws of motion. We learned first law, that is when external force act on a body is zero, then acceleration of the body is zero. Or if net external force on a body is zero, then the body can either be at rest or it moves with the uniform velocity. In either cases, acceleration is zero. Now, law of inertia, the inability of a body to change the state of motion by its own is called law of inertia. There we have learned inertia of rest, inertia of motion, and inertia of direction. Then momentum P is equal to mv. The product of mass and velocity is nothing but momentum. Momentum is a vector quantity, and momentum is the quantity of the motion. Momentum is the quantity of the motion. So if you are asked, the quantity of the motion is given by momentum or by net external force, which you have to choose. The quantity of the motion is given by momentum, not by force. Now, change in momentum. If Pf is the final momentum and Pi was the initial momentum, then change in momentum is m into v minus u, where v is the final velocity and u is the initial velocity. Now, Newton's second law of motion. Here I have written F is equal to dp by dt. This dp by dt means rate of change of momentum. In order to define this process, it is a long process actually. So just to mean that how to read it. It reads as rate of change of momentum. Rate of, here P is a momentum. So d by dt meaning rate of change. So rate of change of momentum. Rate of change of d by dt means rate of change. So rate of change of momentum. So F is equal to rate of change of momentum, and we derived F is equal to ma. Now another important thing is, if you are given F is equal to dp by dt and F is equal to ma, then you are asked to choose the correct option. Then you have to choose F is equal to dp by dt, not F is equal to ma. There is a slight variation in it, and that you will learn later. Now, if I am talking about it, you may get confused. The Newton's second law is actually F is equal to rate of change of momentum, and we have derived F is equal to ma by considering certain concept. We considered mass as constant, and that is how we derived F is equal to ma. When mass is not constant, F will not be equal to ma, rather there will be a change. But F is equal to dp by dt, always F is equal to dp by dt, rate of change of momentum. F is equal to rate of change of momentum. Now, Newton's third law we learned, to every action there is an equal and opposite reaction. So action is equal to minus reaction. Now the third one, sorry, law of conservation of momentum. If net external force acts on a system is zero, then the momentum of that system is conserved. The momentum of that number of bodies or a single body, the momentum of that entire bodies are constant. If you are adding up all the individual momenta, then that individual momentum will always be constant. Now additional worksheet I am going to explain. So additional worksheet, I have given the question number just as the additional sheet question number. Additional worksheet question number. So for the first question, momentum of the toy car, I am reading. Momentum of the toy car of mass 200 gram moving with speed 5 meter per second. See what are the data given? Mass is given, speed is given. We can take here it as speed as velocity. So what is asked? Momentum is asked. So for the first question, how we are going to answer? P is equal to mv. P is equal to mv, where we are asked to find P. We have given mass and we have given speed. The speed we are considering here as velocity. So velocity is 5 meter per second. 5 meter per second, and mass is 200 gram. See, velocity is meter per second, that is SI unit. Mass is in 200 gram. Mass is in gram. So we have to convert it into SI unit. SI unit is kilogram. So 200 gram is nothing but 0.2 kg. So mass we are having 0.2 kg and velocity we are having 5 meter per second. Now we are asked to find the momentum. Momentum is mv. So P is equal to m. What is the value of m? 0.2. 0.2 into what is the value of v? That is 5. So 5 into 2 is 10. So here we are having a decimal. So we can write it as 1. So what is the unit? 1 kilogram. 1 kilogram meter per second. 1 kilogram meter per second. Now look at the second question. Two bodies A and B of same mass. So if you are considering two bodies, mass A we are considering m1 and B we are the mass of B we are considering m2. Then same mass meaning m1 is equal to m2. Okay, so we can write m1 is equal to m2 is equal to m. We can take m1 is equal to m2 is equal to m, since the masses are equal. Now moving with velocities v and 3v. If you are considering v is the first the velocity of A, then 3v is the velocity of B. So now we are asked to find their ratio of their momentum. See, two bodies A and B of same mass are moving with velocities v and 3v. Then their ratio of their momentum is, we have to find the momentum of A is to momentum of B. So we are just considering the second question. What asked is, if you are considering momentum of A as P1 and momentum of B as P2, then we are asked to find ratio of momentum of P1 is to P2. P1 is to P2 is we need to find. For that we have given the information regarding with mass and regarding with velocity. So we can write here. What about mass? Masses are same. So here m1 equal to m2 equal to m. Okay, m1 equal to m2 equal to m. v1 velocity of A is given as v. So v1 is equal to v, and velocity of B, just take v2 as 3v. So v2 is equal to 3V. Now P1 is, we can write P1 as M1 V1. So M1 V1 is nothing but P1. Okay. So P1 is to P2. P2 is M2 V2. Well, the momentum of A is to momentum of B. Now just look at it. M1. What is M1? M1 is nothing but M. M. What is V1? V1 is V. So M V is to. What is M2? M2 is again M. And what is V2? V2 is 3V. So that is MV is to 3MV, right? M into 3V is nothing but 3MV. So which can be written as here MV and MV get cancelled. So 1 is to 3. So the ratio of the momentum of A and B is 1 is to 3. Now we are looking at the 7th question. There is certain interesting thing is there. First I am reading the question. A 150 gram ball traveling at 30 meter per second strikes the palm of player and is stopped in 0.05 second. Force exerted by the ball on the hand is by the ball on the hand is. So imagine there is a player. The player is taking the catch. So while taking the catch, initially the ball was moving with velocity. We are considering velocity 30 meter per second. So initial velocity of the ball is 30 meter per second, and as it receives in the hand, the player draw back to backward, and in order to increase the time, that is another concept. So I am not going to in the deep in it. In order to increase the time, we are just moving back our hand while receiving the catch. Now, so the initial velocity of the ball is 30 meter per second, and he is receiving the catch in an interval of time 0.5 seconds. So in order to receive the catch, he took the time of 0.5 seconds, and when the catch is fully received, then what about the velocity of the ball? The ball is stopped. So he is stopping the ball. So the initial velocity is 30 meter per second, and final velocity is, see, when it is stopped, the velocity is 0. So the final velocity is 0, and the time taken is 0.5 second. So we have given mass, we have given initial velocity, we have given final velocity, also we have given time taken. So which equation is best to substitute in order to find the force? That is F is equal to m into v minus u by t. So we are taking 7th question. Answer we are taking F is equal to m into v minus u by t. See, this is a force. Initial velocity of ball, final velocity of the ball, time taken to change the velocities. So this is a force acting on the ball. Force acted on the ball. So here F is nothing but force acted on the ball. The ball changes its velocity because force is acted on the ball. Who acts the force actually? Who is the agent actually? We can say the player is exerting force on the ball, as well as the ball exerts force on the palm. So two forces are there. One is the force exerted by the hand of the player or palm of the player. Another one, the force exerted by the ball on the palm. So these are action reaction pairs. Okay, so here first we are finding this is the force exerted by the hand on the ball. So because the velocity of the ball is changed, so force is acted on the ball. That is what we are considering. So here F is nothing but force acting on the ball. Force acting on the ball. F is equal here M. What is M? M is equal to 150 gram. 150 gram. Everything is given in SI unit except the mass. So we can change the mass now itself. 150 gram is nothing but 0.15 kg. 0.15 kg. Now initial velocity is u is equal to 330 meter per second. U is equal to 30 meter per second, and final velocity it is given as the ball is stopped. When it is stopped, the velocity v is equal to 0 meter per second. Now time taken t is equal to 0.05 second. So these are the data given. We are finding the force acting on the ball. What we are asked to find force exerted by the ball on the hand. Force acted on the hand we have to find. But first we are finding force exerted by the hand on the ball. So force acted on the ball is equal to, we can write F is equal to, substitute the values. Mass is 0.15, velocity is 0 minus 30 whole divided by, you can write it as whole divided by, what is the time taken? 0.05. See, 0.15 is the mass, final velocity, initial velocity, time taken. Okay. Now here two decimals are there. Here also two decimals are there. So we can multiply with 100 both in numerator and denominator. So it become, here it become 15. Here it become 5. So I am just writing 15 into minus 30. 0 minus 30 is minus 30 divided by 5. So here it is 15 divided by 3 is nothing but 15 divided by 5 is nothing but 3. 3 into minus 30. So that is, we can write it as 3 into 3, 9. So 90 Newton. So minus 90 Newton. Here velocity of the ball is decreased from 30 to 0. So force is acted opposite to the direction of velocity. That is why we are getting minus sign. The minus sign denotes the force is acted opposite to the direction of velocity of the ball. So now we are finding force acting on the ball is minus 90 Newton. Then force acted on the hand by the ball we can take as force on, now force on hand. Force on hand is equal to, we can take it as 90 Newton, right? We have taken action as minus 90 Newton, then reaction is 90 Newton. So the force acted on the hand, force acted on the ball is 90 Newton, whereas force acted on the ball is minus 90 Newton. So these are the questions we have explained. 3 questions we have explained and we have revised the chapter. So from tomorrow onwards we will take a new chapter, or we will learn a new chapter. So revise this chapter today itself. Okay, thank you.